Okay, let's work on converting back and forth between exponential form and logarithmic form. I always found if I'm starting off with exponential form, it's a good idea if you want to identify who is the base and who's the exponent. That'll help us fit into the logarithmic form when we try to write this. So let's identify this for both cases. Let me see if I can. With 2 to the 5th equals 32, my base is 2. And I don't have to say equals, I'll just say 2. And my exponent is 5. This is going to help me out with logarithmic form because I know in log form, you always have to have the log in there. And remember with logs, the base of the log is the same as the base as when we're talking about exponential form. So if the base is 2, your subscript would be a 2. Another key element that we got back and forth when we're going through this section is that when someone asks you, what's a logarithm? The easiest way for you to respond is for you to say it's an exponent. So kind of a key in this, a logarithm is an exponent. So this helps me when I go from exponential form to logarithmic form. I know that I'll have to set my log equal to whoever the exponent was. And so in this case, the exponent was 5. So the logarithm is equal to 5. Now, the only thing missing is the argument of the logarithm. You can't have a logarithm without an argument. So the only other number that we have not addressed is the 32. And so that is the argument of the logarithm. So now we have exponential form to logarithmic form. Let's do the same thing with 7 to the 1st power equals 7. I will go along with just identifying who my base is. In this case, the base is 7. The exponent, in this case, is a 1. And so when I rewrite everyone in log form, log, that's the first step. The base is 7, so we have a subscript of 7. I'm going to leave a little space. And keyword, what's a logarithm? A logarithm is an exponent, so you're going to set the logarithm equal to the exponent. In this case, it's a 1. The only other number we are missing is the result, and that will be also a 7. I'll write that in there for you. So log base 7 of 7 is equal to 1. One more time, with 5 to the 0 equals 1. My base is a 5, and my exponent is a 0. So when I convert to logarithmic form, log, log, the base is the subscript, so the 5. Now logarithms are equal to exponents, so we're going to set that logarithm equal to 0. And the only other number we have not addressed is the answer to the exponent expression, which is a 1, so that is our argument. So that is how I convert from exponential form to log form. And we're going to go the other way now. And sometimes, you know, depending on what form that you like, usually when we're in exponential form, it's because we like solving equations with exponents. However, sometimes in later math, it's easier to rewrite something as a log because it might be easier to take a derivative or integrate something. Either way, it's very nice to get flexible with going back and forth between the forms. So we can take this the same way. I'll start off with kind of identifying in terms of what's happening on the log side versus the exponential form side. You could go back and say, well, who's my base? Of log of 1/2 of 8 is -3. The base is 1/2. And what you can go from there is you can say, well, I always know that logarithms are exponents. So you could go back and kind of use this notation, the exponent, even though we do not see it as an exponent like we know and love, we do know that the exponent is what the log is equal to. So the exponent's -3. So what happens when you want to write an exponential form, the base is a 1/2. The exponent is -3. And so the only other number that is left over is the argument. And if you'd like to write that, that's okay. Kind of get in the hang of it. The argument's 8. So that is what the exponential expression is equal to. Now I know, because these are nice examples with nice concrete numbers, you might be able to figure this out without having to know the pattern. But keep in mind, a lot of these numbers get replaced with variables, so we have to know the pattern first. What I might do also, I like to kind of show you another way to look at this. It's kind of a cute little circular form. If you look at the logarithmic form one more time, you can take the base, raise it to the other side. So 1/2 to the -3 equals 8. So we have ourselves kind of a circle. 1/2 to the -3 equals 8. And sometimes this is after I've done a lot of these, I start looking at this way, because it makes it a little bit faster. So we'll do the same thing. Log base 2 of 16 equals 4. Feel free. We can go the shortcut way. We can say, okay, 2 raised to the 4th power, that's 2 to the 4th, equals 16. That works out well. If you want to double check yourself, you can just start naming the components of the logarithmic form. For example, the base is 2. We have that right here. The exponent is 4. And it looks like I erased that. I apologize. That's a 4. And then the argument is 16. And so we have our answer. So one more time. I'll take the shortcut form, and then we'll think backwards. 10, that's the base, to the other side. 10 to the 3rd power equals the argument, which is 1,000. So that's our exponential form derived from our log form. Go back really quick. The base is 10. The exponent is 3. And the argument is 1,000. And now you have a little bit of example of going back and forth between exponential form and logarithmic form. Practice, practice, practice. This will come back in different parts of your mathematics. If you get good at it now, you'll have a good time later. I'll see you in the next example.